This demo highlights the capability of EMC technologies such as VFCache, VMAX 10K, FastVP to accelerate the performance of mission-critical enterprise-class SQL Server 2012 virtual infrastructures. We'll first talk about the architecture design of the demo environment. Then, VFCache configuration in a VMware environment will be demonstrated. Next, we will show the benefits of enabling VFCache. The performance impact of VFCache on a two-tier storage system with a storage bottleneck will be demonstrated next, followed by the impact of VFCache on a three-tier system with storage optimized for SQL workload. Architecture design. 4 mission-critical active OLTP databases totaling 1.8 terabytes of data are replicated to the secondary server using the always-on availability groups. This solution is provisioned on EMC Symmetrix VMAX 10K with FastVP and features the always-on availability group readable copy on the secondary server. All SQL servers are virtualized with VMware vSphere 5. EMC FastVP technology automatically places the most important data on high-performing drives and pushes less active data to lower-performing tiers while still keeping it reachable. EMC VFCache card is installed on the ESXi server hosting the primary SQL server. We'll take a look at the impact of VFCache on two-tier storage system where a storage bottleneck exists, and how VFCache can help to remove that bottleneck first. Then examine VFCache on a three-tier storage system that's optimized for SQL Server workload to show how it can offload the OLTP workload and reduce the utilization at the storage array level with minimal impact on system resources and improve the performance of SQL Server. This is the storage design for SQL Server. For the databases that will get the heaviest load, database 2 and 3, 6 database lawns are created to distribute the workload. Primary and secondary database lawns are designed to be identical. Only the database lawns for the primary server are served by VFCache. All log lawns and the TempDB lawns are excluded from the VFCache pool. The video clip next will show how easy it is to configure the VFCache to work with VM.
After the VFCache card is installed on the ESXi server, the VFCache LUN can be configured in the ESXi server via the vCenter VSI plugin. If this is the first time using the VFCache after a new install, enter a username and password to the VFCache agent. Once logged into the agent, the device can be used for all VMs in this ESXi server as a cache device. Go to the ESXi server hardware configuration and add storage. Select the VFCache card. It should appear as an SSD device. The usable space for the 300 gig card is close to 280 gigabytes. Choose VMFS5 as the file system type and provide a descriptive name for the data store. The VFCache data store can now be used to create a VFCache device for each VM that's on the ESXi server. Go to the EMC VSI tab on the VM that's going to have the VFCache device and enable VFCache remote management if it's not already enabled. You'll now be able to create a VFCache device. Type in the size of the cache device that's desired. Here, we will use the entire capacity of the card to provide maximum performance boosts for the primary SQL server. Next, add the VFCache device to the VM. Once the cache device is available, you can select source LUNs that need a performance boost. The selections in the list correspond to the hard disk number in the VM. After all the source LUNs are selected, the configuration of VFCache is complete, and it starts caching immediately unless you stop it. The VFCache device is shown in the VM as a basic disk with an OEM partition.
Test results. In this environment, there are 16 data lawns, a total of 1.8 terabyte data on 3 terabyte lawns, configured to the single VFCache device with 278 gigabyte usable cache space. After enabling VFCache for the first time, the performance boost was visible immediately. It took about 1 hour to reach the steady state with maximum performance boost. We tested VFCache with two-tier storage system that could only support half of the designed SQL Server workload to see the impact of VFCache. As expected on the system suffering from the storage bottleneck, the SQL Server transaction rate was low and the response time was high without VFCache. The response time for queries trade lookup and trade update dropped nearly 50% when VFCache was enabled. These are queries with most read operation. In this test, adding VFCache to the environment also increased the SQL Server total transaction per second to the system. When adding VFCache to this environment, the host IOPS also increased to a much higher level. After VFCache was enabled, host IOPS increased 10,000. Storage backend IOPS decreased slightly. SQL Server transactions almost doubled. Read latency reduced to approximately 1/3, while the write latency increased because of the almost doubled transactions. Adding VFCache to a two-tier storage system with storage bottleneck increased the total number of SQL Server transactions that can be handled by the host. The increased host CPU usage came from the additional SQL Server transaction workload rather than servicing of VFCache itself. Compared with the same SQL Server transaction level supported by optimized storage with no VFCache, the CPU usage was similar or less in this case. Before VFCache was enabled, the read-write ratio was consistent on the host and the VMAX 10K. After VFCache was enabled, the read-write ratio increased on the host but decreased on storage backend. Read IOs on the host increased approximately 10,000. Write IOs increased about 23%. Total host IOPS almost doubled while backend IO decreased modestly. We also tested VFCache on optimized storage system with 3 tiers that could sufficiently support the designed SQL Server workload to see the impact of VFCache. The same workload was used to compare the performance before and after VFCache was enabled. The improvement from VFCache to the SQL Server response time is much more dramatic on queries with more reads and higher response time. Trade lookup and trade update are 2 of the queries that have more read operations and take longer to complete. After VFCache is enabled, these 2 queries' response times drop visibly around 30% or more. While all 3 tiers in VMAX 10K storage array provided the SQL Server with sufficient IOPS, adding VFCache reduced 50% read latency. It offloaded about 10,000 IOPS from the storage array backend for reads. The client SQL Server transaction were also improved. By freeing up the storage array load, VFCache enabled the storage system to handle more client load with better performance. Because VFCache is a write-through cache, writes are all going to the storage array directly, not affected by VFCache. The CPU usage only increased 0.4% after VFCache is enabled. This indicates that VFCache has minimal impact to the SQL Server resource. Read-write ratio on the host was very consistent before and after VFCache was enabled. However, the read-write ratio on the VMAX 10K changed to close to 80-20 because VFCache offloaded a large portion of read I/O from the storage backend. To summarize, EMC VFCache is well suited to support enterprise-level SQL Server 2012. It is very easy to manage and monitor in the VMware vSphere environment. It can significantly lower SQL Server response time for queries with a large amount of reads and high response time. VFCache has minimal impact on system resource in a VMware environment. Only about 0.4% increase of CPU usage contributed by adding VFCache to the server in our testing. It offloads read I/O from the storage while reducing the disk latency. VFCache can immediately improve the system performance after being enabled. The initial warm-up time before it reaches its maximum performance boost depends on the environment. In our test, for 16 LUNs hosting on 3 TB storage, a single VFCache card of 278 GB usable cache space reaches its maximum IOPS in about 1 hour. Thank you for viewing this demo. For more information, please visit our website www.emc.com/SQL.